Alright, today we're going to do chapter 2.1, which is arc lengths. Okay, before we start on this chapter, let's just do some basic revision from primary school. Okay, first we need to remember that the circumference of a circle is given by the formula 2 pi r. So the circumference would be this whole thing here. Okay, and the area of circle is given by pi r squared. So this would be the area over here. Okay, now we need to learn a few different terms there. So given in figure 1 on page 39, alright, so just imagine there's a circle. So for the circle, first and foremost, if we draw a line across like this line CD will be known as a chord. And then with this line, notice that it divides into two areas. There's a bigger area here and there's a smaller area here. How we term this is by the word segment. So major segment, minor segment. So just imagine you have a birthday cake, you take a knife, just cut it across here. It divides it into major segment and a minor segment. Now, the other way that we can divide a birthday cake, so to speak, is from the center, we cut and we cut. OA and OB are both the radii or the radius of the circle. So in this case, we are cutting like a slice of the cake. So same thing now, okay, so if we divide it this way, like that, the slice that we take out is known as the minor sector, and this arc, right, is known as the minor arc. Similarly, the piece that is left over down here, this is known as the major sector, and this arc over here is known as the major arc. Okay, if you remember very quickly, okay, from primary school, if I wanted to calculate given these two diagrams, I focus on this diagram here first. If I wanted to actually calculate this arc length here, this is a quarter circle, what do I actually do? Okay, so first I'll say it's 1/4 times 2 pi times r, okay, which is 3 cm. So I have 63 over 2 pi. So in this case, I have calculated the arc. Okay, notice that without even asking, you could tell me that we use 1/4. Okay, this will be important later. Okay, similarly for this diagram over here, if I were to calculate my arc length, in this case, this arc length, this one in red color over here, what I get is half. Why half? You tell me, oh, because it's a semicircle, so it's half times 2 pi times r, which is 5 cm. So what I get is 5 pi cm. Okay, just think about it for a while. How do we get half? How do you think half, okay, is related to 180 degrees? If you just think about it, what we have is 180 degrees. The whole circle, okay, what will be the angle here? It will be 360 degrees. It looks like a pokeball. Okay, so basically half actually is a proportion. It's actually 180 over 360. That's how I got the half. So it's like the proportion of the whole circle. Similarly, this is 90 degrees. Okay, 90 out of the entire circle is 360 degrees. So if you know, 90 over 360 is equals to 1/4. So what we have is 1/4. So what I'm saying here is this: the angle, okay, is related to the arc length. Just imagine, for a small angle, you have a smaller arc. For a larger angle, you will have a bigger arc. So in essence, the arc length is proportional to the angle. So there is a formula that we need to know now, okay, which is x over 360 times 2 pi r. So this can be found on page 40 of the textbook, and this is a formula that is not given. You will have to memorize this. And today we'll just work with this formula for the entire session. Okay, now first and foremost, what we will have here is this. We have the radius of a circle is equals to 8 cm. The arc extends at 135 degrees at its center. Find its length. So what I can suggest to you now is this. You can just take some time now and try to sketch out a diagram. for this case. So how would this arc CQD actually look like? Okay, now if not, I will start to sketch it out for you. So 135 degrees should look something like this, and then this is the arc over here. So what we will have here is this. So they want me to find the arc length over here in orange color. So what I'll do here is this. I will apply the formula that we have just learned a short while ago. The arc length equals to 135 degrees over 360 times 2 pi r. Okay, you might be wondering, why is it 2 pi r? Because 2 pi r is the entire circumference of a circle, and this 135 over 360 gives us the proportion of the entire circumference of the circle that we actually want. So in this case, if you just use a simple computation, what you get is 18.8 cm. Correct to 3SF. Okay, I'm on page 41. We have tried to. The minute hand of a clock is 10 cm. How far does the minute hand travel in 40 minutes? So, okay, basically we need to find the angle. So in 40 minutes, just imagine you're at 12, okay? Then 1, 2, 3, 4, 5, 6, 7, 8, that is 9. Okay, so from here to here, all right, what is this angle over here? So basically what we need to do is we need to find the angle first, and then once we have found the angle, they say how far does the tip travel. So basically we're trying to find the length of this arc in orange. So now I will begin to find the angle of rotation in 40 minutes. So in 40 minutes, okay, what I get is 40 over 60. Why 60? Because that's 1 hour times 360 degrees. So what I get is 240 degrees. So in my diagram, this angle here is 240 degrees. Hence the distance, okay, which is the one in orange, will be equals to 240 over 360 times 2 pi times r, which is 10 cm. So in the end, what I get is 41.9 cm. Now they ask how long will it take to move 30 cm. Okay, so now let me just do the working on this right hand side here. So I will say that x over 360 times 2 pi times r. Okay, so I'm trying to find arc length, and the arc length in this case is 30. So how do I solve for x? Okay, so x is equals to, okay, 360, I multiply to 360 upwards, then I'll divide by 2 pi and 10. So what I get is 30 times 360 divided by 2 pi divided by 10, like this. So the angle that it moves, right, or what the angle it moves to move for it to move an arc of 30 cm is actually 171.89. So this is the angle that it moves, right, for the tip to move 30 cm. Hence the required time is equals to 171.89 over 360 times 60 minutes. So what proportion of 60 minutes? We will know that is 28.6 minutes. Okay, now we are moving on to page 42. We have tried 3. Okay, now they say find the distance of the curve from the center O. So the distance of the curve, so basically this thing here in black is the curve. Try to find the distance. So in essence, what are we trying to find? That's right, we're trying to find the radius. So in this case, what I can say is this. I will say let the distance be r. So if I apply the formula, x over 360 times 2 pi r equals to arc length. So I say 135 over 360 times 2 pi times r equals to the arc length of 35 meters. So again, we just do some calculation. 360 will multiply upwards. The 135 and 2 pi will come downwards to give you 2 pi and 135. So what I get is r equals to 35 times 360 divided by 135 times 2 pi. So in this case, the radius or the required distance is 14.9 meters. Okay, this is the final example for today. It can be found on page 42. Okay, so for page 42 is this. We have tried 4. Alright, we will find a piece of wire is 80 cm, is bent to form a sector of a circle. Okay, so if I draw a sketch of it, so it's 130 degrees. Okay, and then we have the arc down here. Okay, now if I say this, if I apply the formula blindly, I say 130 upon 360 times 2 pi then times r, okay, is equals to 80. Am I right or not? Okay, in this case, I'm actually incorrect because this only gives me the arc length. What am I still missing? So don't forget the wire is bent to form a sector. So in this case, it actually means that the wire is not only made up of this arc length over here, the wire is also made up of these two portions here in green, which is the radius and the radius. So for me, what I need to do is I need to modify my equation here. So I say is plus 2r. This is the 2 radii. Because it's the entire wire makes up the entire sector over here. So now if I start to simplify my equation, so what I'll do here is this. I will just say that 2r, okay, let me just move the 2r over here to avoid confusing you. Okay, the arc length itself, if you just use your calculator, what you do here is this. Just use calculator, you take 130 over 360, then times 2. Okay, leave out the pi first, alright? So what I will get here is this 1360 times 2. I will simplify this whole thing to 13 pi over 18 plus 2r. Okay, sorry, there's an r here, equals to 80. So how do I simplify this? Notice that the common factor is r and r. So if I factorize r, I get 13 pi over 18 plus 2 is equals to 80. How do I solve for r? I just take 80 divided by 13 pi over 18 plus 2. Simplifying that, what I would get is the radius of the circle to be 18.7 cm. And that concludes this section on arc lengths. You may